Hello. I'm Alexey Fedorov, and this is the first episode of Test-Driven Development Screencast. Today I'm going to briefly address following questions about test-driven development. What TDD is, and what are main benefits of doing TDD. At the end I'm going to demonstrate a small example on how to implement simple sorting algorithm using TDD. Let me open my slides. Don't worry, there are only 3 small slides. Okay, so TDD, first of all, is a software development discipline, which means that its basic rules are arbitrary, weird, and are to be followed to the letter. If you want it to be useful for you, if you want it to actually work as it intended to work. There is a reason for that, but I will talk shortly about it. Let me read the rules themselves for you. So first rule says you're not allowed to write a line of production code unless test fails. Which means that I'll have to write the test even before I have something to test. That's a very weird concept, and maybe it sounds stupid. Maybe it's not. But the next rule, believe it or not, is even more weird. You're not allowed to write more of a test that is sufficient to fail. And it is important to clarify what fail is in this context. In this context, it means either test expectation failure, which means that you return the wrong value, not expected value, or compilation error, exception, parsing error, interpretation error. Depends on what you use. If you use compiled language or use dynamic or static compiled or interpreting language. What that means? That means that you will have to interrupt yourself. You can't even write the whole test. You can only start writing it and it immediately fails because class is not found that you just mentioned, and you have to go in your production code and create this class. This may sound even much more stupid than first rule, but bear with me. Third rule is even more strange. You're not allowed to write more production code that is sufficient to make the failing test pass. Which effectively means that once you have defined a class that was mentioned, you have just fixed the failing test. And you have to go back and write more of a test, and you have no right to write the contents of this class that you just defined. And the interesting thing that most probably you will go to your test, create an instance of your class, and then you're gonna call method on it, but method is undefined, which means that you have to stop and go through your loop again. You will have to define method, which will be empty. Once you define it, you can't write its body because test no longer fails, and that's when you can actually expect something. You can expect this method to return some value or change some state if you would like to. That all means that once you change your production code only slightly in the direction of correct code, it's not yet the correct code, and it not yet even resembles it, but you have to go write more tests. This is a very interesting concept, because now you get yourself in a very tight lock, in a very tight feedback loop. Write line of test, write line of code. Write half a line of test, write a half a line of code. Write a line of test, write a line of code. Spot duplication refactor. Write a line of test, write a line of code. And so on and so on. Length of this loop usually 5, 10, 30 seconds. If you have the test that needs to run half an hour, you will not be using TDD. You won't run tests. You would probably just use CI for that, something like that. So it is a good idea to design a test suite or your test runner that it will run only relevant tests, which will make, even if you have huge test suite of thousands, tens of thousands of tests, and millions of tests. But when you change something, it is important to run only relevant tests. And that's how you can achieve feedback loop of 15 seconds even if you have a couple of millions of tests. So, you may ask, why should I follow to the letter? Why can't I follow it generally, but sometimes don't follow? Well, you can. What happens in this case? What happens if you sleep there, if you write a bit of production code, a bit more than you had to write to make test pass, then you write a bit more tests that you had to make it fail, or even worse, if you wrote your test after the implementation. So you implement the whole method, and then you covered it with tests. You think you covered it. I don't think so. Maybe you covered it, maybe not. You can prove it. You can, but it's harder than doing TDD. So, what happened there is that if you don't follow TDD to the letter, but you step back from some rules, do dirty things, you may end up as those people who think that 70% test code coverage is something to be proud about. I don't think so. That's not an achievement. That's not even a minimum that you should have. So you may ask, 100% test coverage, that's an unachievable goal. Yes, it is an achievable goal. That's your bar. That's where you have to go. You will never arrive there. But that's not an excuse to have 70% test coverage, or even 85. 98 might be good enough, might be not. Might be that you need 99.9 because your system is so critical. So, okay, let's imagine that we have 70% of our code covered by tests. What happens in this case? What can you say about this code? What can you say about this test suite? I know what could be said, but what I would say and what I would think about test suite that I can't trust it. Because that means that 30% of the code is not covered. That means that if I gonna change existing code, I can't be sure that I actually did the right thing, that I didn't broke something. And let's imagine following scenario. 70% test coverage. You open a file on your screen. You never seen this file before. You just double in different part of the domain of your code base. You spot some nasty duplication and you're like all OCD and you want to fix it and you know that you should fix it. And you already see how to do it obviously. Just extract this thing and this thing and this thing to the common variable, for example, something like this, and reuse it. Something simple. And now you put your hands on your keyboard. And now fear overwhelms you. What about test coverage file? Look it up, open some HTML file, see, oh, it's bloody red, it's not covered, half of this code's not covered. How am I gonna to make sure that I didn't broke it? I don't touch it. That is most expected reaction. I don't touch it. I didn't touch it because I didn't want to break it and I don't want to cause my company to run out of business. That's what it is about. It's about fear. Is it that your code that fears you, or you who fear your code? That's an important one. That is an important question. So now let's imagine a different case. You're doing TDD and you have 100% code coverage. Well, maybe 98. And same scenario. You open a file on your screen. You spot some nasty duplication. You obviously fix it. You run test, they are green. You check in code to code source control system. Code just became cleaner in a matter of seconds, probably. There was no fear. Okay, so what happens if tests actually fail? You spot a long method in the same file. You split it into 3 methods. That's agree? Awesome, cool. But now see that those 3 methods don't belong to this class. They should be in their own class. You do that. You extract the class. You put those 3 methods there. And you run tests. And they fail. No fear at this point. You just press undo a couple of times. And you're back to green state. You examine the failure. You see, that's why it failed. You fix your mistake. You run tests. They are green. Everything happened with, if you have good test time, like 5-10 seconds, then it might happen in under 60 seconds. And again, you just checked in the cleaner code. Undo button is interesting button in TDD. That's your friend. That's your best friend. Because once you're feeling confused, or you don't know what you're doing, or you don't understand what's going on, and of course your tests are failing, it just happens that 25 seconds ago everything worked. And that's exactly 3 undo away from current state. So I press undo button 3 times. And I'm back to the state when I knew everything worked and I understood everything, or at least in this context. And now I can think what was actually happening there. But I'm not somewhere in the woods, in the wilds, lost, never to be found. So that's the main reason to do TDD. Main reason and main benefit. There are multiple other benefits. They are not that important. This is most important. Elimination of fear. You should control your codebase, and codebase shouldn't control you. Okay. There is hidden rule of TDD. It is more of like implementation detail of TDD. That's one way to do it. But I think it's awesome. Sorry. So, as you can see here at the end, on the one line to the slide, hidden rule says, as tests become more specific, production code should become more generic. And it's very true if you think about it in detail. Otherwise, you would end up with a bunch of ifs each time you add a failing test. You won't do that because that's a duplication violation of dry principle. What you do instead, I will show during the example. So let's sum up. Last slide. If you have 100% code coverage, or at least that's your bar that you set, and you're probably very near to it. You don't have fear while changing code, while implementing new features. And that means that you will constantly improve your code. You will make it cleaner. You will not allow it to rot. That's what you see on the screen. Consistent random kindness to the code. That's a very good term, and it's coined by Bob Martin. I really love it. Random kindness to the code. You should be kind to the code. And if you are kind to your code, it will be under your control. And as a result, you get clean code base. It will be cleaner and cleaner and cleaner over time. Even if you had clean to begin with, it will not rot. It will not go to mess. But if you don't do TDD, you have like 60% code coverage, where 60 could be anything between 0 and 90 something, 96, 95, 97. So here there is major problem, you have fear to break it. And the reaction I won't touch it, which results in a huge big pile of mess. Okay. I think that I'm out of time here, so see you next time, and we will start right away from sorting an example, which will be just small examples in implementing it through TDD and without thinking algorithm beforehand. Okay, have a nice day. Thank you.